The Advent of Code is a nice puzzle sorting event that happens every year, and I really like to solve it. And I really endorse if you want us to actually get into coding and puzzle solving to try it. And today I'm gonna start working on the each of days of the Advent of Code, but I'm not gonna show here the code or the solving or how to solve the issue. I'm gonna show the logic I'm going through to solve that problem. So let's go back here to the screen and show you. This is the first one. So like, let's go here first. So you have the first day. I haven't solved the second day yet. I have 12 hours to solve it. So let's go to the first day. The first day actually is really interesting. And here's the story. So the chief historian is always present for the big Christmas, slight lunch, but nobody's seen him in a month. So the idea is now you have to figure out where the chief historian is, and they try to check location that he most likely to visit. So each location is checked. They will mark then on the list with his star. They figure the chief historian must be in one of the first 50 places, and they will look. So in order to save Christmas, you need to have get 50 stars. So 50 stars is the star that you're gonna get solving the puzzles. Okay. So now that is so that's this. Okay, so you haven't left yet. The tail group of senior historians has already hit the problem. Their list of locations to check is currently empty. So someone has that the best place to check. The first would be the chief historian's office. So when they got into the office, everyone confirmed that he's indeed nowhere to be found. So that's the first one that he started. Instead, they discover an assortment of notes and lists of historically significant locations, and they start to do this as they name it a location ID, and then each of the historians they split into two groups, and they start holding two lists side by side, and they see that's not exactly the list, not exactly the same places ID. So you can see here that's the two lists side by side. So this is one list, this is the other list, and maybe the list is of a small amount. And to find out, we have to do this. So if you pair up a 3 from the left list with a 7 from the right list, this is not the same number. The distance apart is 4. So you want to get this guy and this guy and see what is the distance between them just by the numbers. Okay. So this is into list apart, and distance would be as follows. So the smallest number in the left is 1. So then the smallest number in the right list is 3. The distance between them is 2. So the idea is to get these guys and get by the smallest numbers to the biggest numbers, and then pair them up and do the distance, and then they calculate the distance. So we have to do this, and then you find the total distance between the left and the right list, and add up the distance. So it's very simple. This one is not that kind of big deal. So the first thing is we have to do. So we have here the list, right? So the next thing you have to do is actually get in the list. So for example, the list one is 3, 4, 3, 4, 2, 1, 3, 3, right? And the list 2 is 4, 3, 5, 3, 9, 3. Wait, 4, 3, 5, 3, 9, 3, 3, 4, 2, 1, 3, 3. And the first thing you have to do here is to sort the list, because you want to get the smallest number. You want to start with the smaller number and go to the top number. So if you sort it out, on this example here, we sorted them out here. So like sort 1, you're gonna be like 1, 2, 3, 3, 3, and 4. And sort 2 would be 4, 3. No, sorry. It's 3, 3, 3, 4, 5, 9. And then now you can pair them up. So this is gonna be using any language. You can pair one list to another. So this would be an array, right? This would be an array, and this would be another array. And then you could check out these two arrays and then calculate the distance between them. But you have to see that in some point, so for example 3 and 5, so if one, so if you see like 1 minus 2 is going to be minus 2, 2 minus 3 is going to be minus 1, 3 minus 2 is going to be 0, 3 minus 4 is going to be minus 1, and 2 minus 2, and 4 minus 5. So what the point is now, when you compare these, you're actually going to see that some numbers can be positive, some numbers can be negative. Let's say that here would be like 5, 5, 5, and 10, for example. You see the first two numbers will be negative and the other numbers will be positive. So what you wanted to do here is the absolute distance between the points. So no matter if it's negative or positive, your number has to be absolute. Because then when you calculate the difference between them, no matter if it's positive or negative, you do absolute, so it's going to be a positive number and it's going to be a positive integer. That's the way that you do it. And then after that, you're going to sum all of them, and then you're going to have the result of the distance or sum of the distance. Very simple one. And then the second one is say that only confirm that everyone fit two lists of the identical and very different. So, or are they? The issues can agree which group made a mistake, so how to read most of the chip's handwriting. But in commotion, you'll notice an interesting detail. A lot of location ID appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpret handwriting. So you need to figure out exactly how often each number from the left list appears on the right list. Calculate the total similarity score by adding up each number appears to the right list. So what we're going to do here now, so we have this list now, right? So then number 3, okay, on the left list, so it has to be, sorry, nice, but I forgot now which. Okay, so you need to figure out how often from the left list in the right list. So this is the left list, this is the right list. So how many 3 appears on the right list? Appear 3 times, for example. So first number on the left list is 3. It appears in the right list 3 times. So similarity increase 3 plus 3 equals 9, because the 3 appears 3 times. So this is the number. So what we need to do, very simple one. You're gonna get here. You're gonna do a for loop list. You're gonna do a for loop, where on this for loop, where for each item, so for example, you see on the list one, for loop on the list one, or the sort one, for example, that would be better actually. On the sort one, what you can do here is that you get this number, right? And you compare and you do another for loop to compare with how long on the sort 2. So for loop sort 1 inside here. So for loop sort 1, and again sort 1. Come on, sort 1. You get like sort 1 get an item, right? And then on this item, you're gonna do another for loop on sort 2, and then you compare, and then you're gonna compare here how long when sort 1, sort I equals sort 2, n. That would be the easiest one. So like it's kind of like a forced comparison. You can do it in other ways, but this is very simple and easy to do. And then when you find it, you're gonna assign a object outside here. For example, you could assign an object that can actually add how many times the sort 1 appears, and then after that, so then you're gonna calculate here. So you can just like appears. So you're gonna appears the push how many times, and then after that you're gonna get the sort 1, right, plus the appears. What would you do. So then after that you have to sum all of the similarities. So then this one you would assign to a similarity, and then you're gonna then that's easy. Then you just like some all the similarities, you know. That's what you should do, and it's very simple to do. And I think like you don't take too much time to do that. Sorry, I see that I'm gonna blow the answer there because I don't want to show the answer. But it's very this one is a very simple puzzle. And today I'm gonna go back and I'm gonna start the second puzzle. I haven't done it yet, but it's pretty much it. I think Advent of Code is a pretty nice way on how do you think. And the idea here is so like you have to compare like to like. So you first sort like the both lists in ascending order. So you wanted to sort them, and then you're gonna pair them and compare them, and then you calculate the difference in an absolute manner, right? And then when you sum all the absolutes, then you have the result. And then for this one, on the for each number in the first list, you count how many times it appears in the second list. So for example, so now you see like 3, 4, 2 here, and the second list you have like 4, 3, 5. You see that the 3 appears one time, the 4 appears one time. So then you multiply the number, so like 3 plus 1, 4 plus 1, and then you have 4 and 3. 3 plus 3 plus 4 would be 7. So the result will be 7, for example. So it's very simple to do. And the idea of sorting is that we pair the numbers in the most natural way to minimize, overall distances. And then it will be better as well to do on the second part the for loop to actually to with the sort numbers, because then you'll be easy to actually already find the numbers by itself. There is other ways that like using programming language. Of course, here I'm doing like just a naming logic, but on there is a lot of like there's a lot of helper functions in JavaScript and other programming languages that you can do this in a very easy manner, and you don't need actually to do like 2 for loops, and you can do in different ways as well. But yeah, so that's pretty much that the idea. And thank you very much for watching. And if you like that Advent of Code, I hope you guys start doing it, because it's pretty nice. And the exercise, they're not that easy per day, so each day is getting increased kind of like in complexity. This one I rate like as very easy puzzle, but you have like until near Christmas to solve all the puzzles day by day to get all your stars. And that's pretty much it for today, guys. Please leave a like and subscribe, and leave a comment down below what you like. Okay, cheers, bye.